Hi, Lauren.
Hi,
How are you tonight?
I'm good. How are you?
Good. Okay, my notes say that last time we got through this problem 51,
Yeah.
and
No, actually, no, I don't think we did.
we didn't get through
No.
51? Okay.
Maybe.
Let's talk about 51 again because it's a common type problem. If they give you an arc length like this, they tell us that that is 6 pi.
Okay.
Well, could we tell what the circumference of the whole circle would be?
Um.
In other words, if I have a 30-degree angle and I'm telling you that that is a certain length, well, if I completed the circle, what would the circumference of the circle be if this is 6 pi? How much bigger is the whole circle than that little sliver?
360.
Well, the whole circle is 360 degrees, so how many of these little slivers would fit in a whole circle if I were to draw all of them? In other words, if I were to make the whole circle equal slivers like that. It would be 360 divided by 30, or 12. In other words, the circumference of this circle is going to be 12 times bigger than the length of this arc because the circle has an angle of 360 degrees, not just 30. So the ratio is 30 to 360, or 1/12. So this arc is 1/12 of the total circumference. So that allows us to come up with 72 pi as the circumference of the circle. Now, when you're dealing with circles, remember that if you know circumference, area, or radius, you know everything there is to know about that circle. So if I know the circumference is 72 pi, it allows me to calculate that radius. What's that radius going to be? In other words, now let's look at the whole circle. Well, that's the radius of that whole circle. What's the general formula for circumference?
Oh, I don't know. I don't know these. I don't know circumference and...
Okay, well the two most important ones you can memorize are area and circumference of a circle.
Okay.
Okay, that's going to be huge on the test, those two. So if you know only two formulas, these are the ones you want to know. Now obviously you need to know a lot more than two, but these are right up there at the top.
Okay.
You want to have instant recall of them. In other words, you don't want to sit and have to wonder what the circumference is. You want to know what it is. Because you can't work half of these problems unless you know these two formulas. So if the circumference is 2 pi r, solve that for r. You have 72 pi equals 2 pi r. What's r equal?
It'll be 36.
Yeah. So the radius, we know this is now 36. So now to figure out the area of this sector, let's figure out the area of the whole circle and what part will be ours.
So would it be 36 times 12?
Pi r squared.
Oh.
So it's pi times 36 squared. That's the area of the whole circle. How much of the circle do we have with our 30-degree slice?
I got a huge number.
Well, hold on. Let's not convert it to a number yet. We have pi times 36 times 36. That's the whole circle. We don't have a whole circle. How much of a circle do we have?
1/12.
That's our area.
Oh, okay.
Okay? Now notice the way I wrote it. I wrote it like that for a reason. I don't want to have to square 36. Well, by writing it like this, now all I have to do is multiply 3 times 36, 108 pi is our answer.
Why would you times it by 3.142?
Because the answers are all in pi.
Okay.
At this level of math, you almost never convert pi to a number.
Okay.
That's over and done with. You won't be doing that anymore. I can't promise for sure that that's the case because there are questions on the ACT and the SAT that will require you to multiply, but they'll be worded approximately. Approximately what is the answer? That's when you know that you're going to have to multiply by 3 and change. But for most problems, they're always going to be in pi, just like square root of 2 is going to stay square root of 2. We're never going to use 1.41 for that. 1.41 is an approximation. Square root of 2 is precise. All right. So any question you see on the test that's about arc length, and they give you an angle, know that, well, this angle means that we have 30 divided by 360 of that circle, 1/12. This is 1/12 of a circle, which means this arc length is 1/12 of the circumference, and this area is 1/12 of the area of the circle. Now, this is a particularly hard problem. Not really, it's just multi-step. They gave us the arc length, which allows us to calculate the circumference of the full circle, which allows us to calculate the radius, which allows us to calculate the area of the full circle, which allows us to calculate the area of the sector. So there's like 5 steps in this program, and you need all 5 of them in order to come up with the answer.
Okay.
Okay? But notice that we're at 51 here. We're expecting these to get harder. These last 8 are definitely going to, I don't think you'll be worried that we're not covering hard enough problems, like you were kind of concerned at the beginning.
How could I time myself okay with these problems since they take a while?
Well, first of all, it's unlikely that you're going to have enough time to do all 60 problems, right?
Yeah.
I mean, you're just going to, I would probably run out of time myself. So the most important thing is to make sure that the problems you do, whether it's 55 or 50 or 45 problems, are the easiest 45 problems to do.
Okay.
So the way you would time yourself is when you get to that problem, put a check mark by it, make sure you see all 60 problems, with some time to spare. Don't ever look at the 60th problem on the 60th minute. You have to be ahead of your pace. In other words, you need to hit problem 30 before 30 minutes is up, such that you'll be able to go back and look at the harder problems that you didn't do the first time through. Now, if you're only going to, say, do 45 problems, well, then you're probably going to leave the 15 hardest problems undone. So that's the way I would handle this problem. I would check mark it and come back to it. Now,
Okay.
when say you see all 60 problems, there's 10 minutes to go on the test, and you've got 20 problems that you check marked out of 60. Well, go back one by one, maybe put a double check mark by the ones that are super hard and a single check mark by the ones that are just difficult. So that when you have 10 minutes and you're looking at 20 problems still to do, you can do the ones that are just single check mark. And so the double check mark ones you probably never even get to. But the last thing in the world you want to do is spend 5 minutes on this problem.
Okay.
If the first time through the test you find yourself going over the 2 or 3 minute mark on any given problem, check mark it and go on. Unless you're 100% sure you're on the right track and it's just a question of doing some more arithmetic to get the answer. In that case, take the time. But if you're still struggling with how to solve the problem and you don't know how to do it, definitely check mark it and go on. That's the best strategy you can take.
Okay.
Okay? And if it were me, I would use a single check mark and a double check mark, because this test is going to have easy, medium, and hard. Now, hopefully you'll be able to do all the easy, most of the medium, and a few of the hards. But it wouldn't be a terrible thing if you only get to the medium and easies, and you do as well as you can on those, and you don't even get to the hards. Not that I'm advocating that, I'm not, because some of these are hard, but some of them really aren't that hard, they just look hard. So you have to be able to make that determination, but time is going to be your enemy. In other words, you're going to run out of time, and you're going to have to make choices that you don't particularly like making. So it's definitely going to behoove you to spend most of your time on the easy and medium problems, not the really hard ones. So for this to be less than 0, what has to be true?
That 6a squared
A to the 5th times b to the 7th has to be 0, less than 0, because 6 is positive. Okay? So this is the main consideration right there.
Okay.
Well, let's go through some of these scenarios. If A is equal to B, well, this would be A to the 12th. That's never negative. So we can rule out H. But let's look at some of these here. F. A is greater than B and A is greater than 0 and B is greater than 0, or A is less than 0 and B is less than 0. That looks promising. Well, if A is greater than 0 and B is greater than 0, then A to the 5th is going to be positive, B to the 7th is going to be positive, and positive times a positive is going to be positive. So A greater than 0 and B greater than 0 doesn't work. And in fact, if they're both less than 0, this term will be negative, because when you take a negative number to the 5th power, it stays negative. And this term will be negative for the same reason. You take a negative number to the 7th power, it stays negative. You multiply them both together, and they're going to be positive. So F not only isn't true, but it's the exact opposite of what we want. We want one of these terms to be negative and one of them to be positive. If both of them are negative or both of them are positive, this will not be true. So we want A to the 5th to be opposite sign of B to the 7th. Well, how about G? If A is greater than 0 and B is less than 0, then this has to be plus times minus. That would work.
Yeah.
Or if A is less than 0 and B is greater than 0, A to the 5th will be minus, and B to the 7th will be plus. So their product again will be minus. So G is the right answer. And this problem really isn't hard. Even though it's 52, it's not hard. It merely requires you to know that when you take a negative number to an odd exponent, it stays negative. When you take a positive number to an odd exponent, it's positive. So that's the only two principles you really need to know to figure out this problem.
Okay.
And you could try numbers. In other words, plug in some numbers. Make A 2 and B minus 1 and see what you get. And then make A negative 2 and B plus 1. And if that's still true with either of those conditions, then that's probably the answer. I'm not sure I want to spend a tremendous amount of time on these super difficult problems just because it's not in your best interest.
Okay.
53 has 6 sentences or 6 lines in it. That might make it look tough right off the get-go. But this is very easy. Read it, and you'll see why. So how many did she visit on day 1?
7.
How many on day 2?
21. Wait,
3
no, 14.
more.
Oh, 10.
On day 3.
13.
On day 4.
16.
And on day 5.
19.
That's it. If Mandy met but did not exceed her goal, how many patients did she visit in all during her first 5 days as a nurse?
So A.
No, add those up.
Oh.
It's 30 for these 3, and 35 for those 2, 65 in total.
Oh, okay.
Now see how easy this problem was? This problem
Yeah.
really is a 1 on the easy or difficult scale. I don't know what it's doing at 53, but it's an illustration of just because there's a lot of words in there doesn't make it a tough problem. What is the smallest possible value for the product of 2 real numbers that differ by 8? So give me 2 real numbers that differ by 8.
They're like equal 8 or?
That differ by 8. Their difference is 8. Give me 2 numbers whose difference is 8.
4 and 4?
Their difference is 0.
Oh. Would it be 16? No. 16 minus 8?
16 and 8 works. There's a difference of 8. That's all we need. What's that product? 144. How about 9 and 1? What's that product?
Wait, how did you get 144?
What is the smallest possible value for the product of 2 real numbers? So I multiplied 16 times 8.
Oh.
Here I'm multiplying 9 times 1 is 9. That's smaller.
Yeah.
So we're definitely producing smaller numbers as we make our numbers smaller. Well, what about 8 and 0? That's a difference of 8, and that's equal to 0. Better yet, look at the answers, though. They got negative numbers on there. Negative numbers are smaller than 0. So let's look at a positive and a negative number. You said 4. Well, let's look at 4 and minus 4. They differ by 8. What's their product?
1. No, sorry, 16.
Minus 16. Notice that there's no other answer on there smaller than minus 16. That's got to be our answer. In other words, we found two numbers that differ by 8 that have a product of minus 16. So it doesn't matter. I could keep searching and find possibly one that's less than minus 16, but since minus 16 is the smallest number of their answers, that's all further work I need to do. I know that minus 16 is the smallest possible value. If I try 6 and minus 2, which also differ by 8, that's only minus 12. Not as small as minus 16. Notice that when you're dealing with negative numbers, the bigger the number, the smaller the number. Minus 16 is smaller than minus 12. That's an important consideration to make sure you know.
Okay.
Minus 100 is smaller than minus 10. Okay. Let's go to the next page. That was another problem that wasn't really very hard.
It's like medium.
Huh?
It's kind of like between easy and medium.
Yeah, for sure. Definitely was not real hard. Okay, here's a trig. This is a classic trig question. This is perhaps the most classic trig question, whether you were taking a trig class or the ACT test. How do we solve this problem? They're telling us the value of the cosine of x, and they're asking us the value of the sine of x. Whenever you get that kind of a problem, the first step, draw a triangle and label x. X is an angle, remember. Now, based on the fact that the cosine of x is equal to 4 over 5, how can I dimension that triangle? My goal is to draw all three dimensions on this triangle and then just read what sine of x is from the three sides. So what are two of the sides?
So don't you do like some like SOHCAHTOA?
Cosine, yeah, but you got to know what cosine is. What is cosine?
Opposite over adjacent over hypotenuse.
So which is the adjacent side here?
It's the bottom one.
So that's 4. Where's the 5 go?
On the hypotenuse.
Okay, now I got two sides of a right triangle. I can always figure out the third side. What kind of triangle is this? This is a special triangle. What's it?
Pythagorean theorem? I don't know.
Well, we can use the Pythagorean theorem, but this is a 3, 4, 5 triangle, so this side has to be 3.
Oh.
It's
Okay.
useful to recognize 3, 4, 5 triangles. It'll save you a lot of time and calculations. In other words, if I had to use the Pythagorean theorem to get that, what's the formula? If this is h is equal to what?
H is equal to, wouldn't you do like 4 squared.
Oh, the first words out of your mouth always need to be what? When you're solving a square root of.
4 squared.
No, it's always the hypotenuse is the first term when you're solving for a side.
5 squared.
Minus 4
Minus
squared.
4 squared.
Which is the square root of 9, which is 3.
3.
So that's how we would solve for it if you didn't recognize that it was a 3, 4, 5 triangle. Okay? Now that we have it dimensioned, the problem's easy. What's the sine of x?
It's opposite, or so 3 over 5.
Uh-huh. And this information here merely tells us that it was in the first quadrant, which means all trig functions are positive.
Okay.
Okay? But that's, like I said, this is kind of the quintessential problem for trig, where they give you one trig function, which allows you to put 2 of the 3 sides on the triangle, use the Pythagorean theorem to put the third side on there, and then you could give me all 6 trig functions. Now, if I said, what's the tangent of x? What's the tangent of x?
3 over 4.
Uh-huh. So remember, that first step is to always draw the triangle and label the angle you're talking about. Because if I just draw the triangle without labeling anything, I don't know how to dimension it. I don't know whether the 4, I know the 5 goes there, but I don't know if the 4 goes there or it goes down here. But the moment I put the x, the angle they're talking about, now I know the 4 has to go down there.
Okay.
Okay. That's as easy a trig problem as you're going to get, probably.
Yeah, that was fun.
But it's definitely one you should get. That's a trig problem you should get. They can come harder than that. This would probably be a problem that I would put a double check mark by.
Okay.
And go on. It's not just because it's 7 sentences long. It's because it's not a straightforward question. Obviously, if he doesn't adjust the price, he's going to sell $17.50 times $9.50 per set of books. Right?
Yeah.
In other words, $17.50 times $9.50. Well, they're saying that he'll sell 1,200 more books for every dollar decrease in price. In other words, if he decreased it to $8.50 instead of $9.50, he'd sell $29.50. So that's the problem. And they want us to come up with an expression. So what did I just do? If I subtracted $1, for every dollar I subtract from the price, I'm going to add 1,200 sets of books. So I'm going to sell $17.50 plus 1,200 times X, the number of dollars that I decrease the price by, and that's the number of books I'm going to sell, and I'm going to sell them priced at $9.50 minus X. In other words, if I knock $2 off of the price, I'm going to sell them at $7.50, but I'll sell 2,400 more sets of books. So this expression seems to work perfectly. And I came up with it by just kind of picking numbers. In other words, I tried knocking $1 off, and I know that I'm going to sell 1,200 more books. If I knock $2 off, I'm going to sell 2,400 more books. If I knock $3, 36. So 1,200 times X fits. I'm going to sell 1,750 sets of books plus 1,200 for every dollar that I knock off. The only disadvantage is I'm selling them now for a lesser price. But even still, this is the correct expression, which matches H perfectly.
Okay.
All right.
That makes sense.
Yeah, it's not that hard of a problem, but it's definitely a higher degree of difficulty.
Yeah.
Okay, this one's got 10 sentences. But it's a probability problem, so it might not be very hard. We've got marbles numbered 00 through 44, which means there's 45 marbles. A player draws a marble. Without replacing the first marble, he draws a second marble. If the numbers on both marbles drawn have a sum greater than 45, the player is a winner. If the first marble drawn is numbered 17, what is the probability that Martin will be a winner on the next draw? Easy problem, actually. We need the sum of the two marbles to exceed 45. So if the first marble had a 17, what does the second marble need to have on it? What number added to 17 equals 45?
28.
Okay, but it has to exceed 45.
Oh.
So we need that second marble to be 29 through 44, one of those numbers. Right?
Yeah.
How many numbers is that?
15.
If I said 1 through 3, how many numbers is that?
-2.
Is it 2? How many numbers is 1, 2, and 3?
Sorry, what? My computer cut you off halfway.
Okay. We're trying to figure out how many numbers are there from 29 to 44. It's not 15. How many numbers are there from 1 to 3?
1.
How many numbers are there from 1 to 3? 3. 3. 1, 2, and 3. And yet, you didn't get it by subtracting these two numbers. When you're dealing with numbers where the numbers are inclusive, in other words, we have to count 29 and we have to count 44, you take the difference and add 1. There are 16 numbers that work.
Oh.
You don't believe me? 29, 30, through 44, count them up, you'll find 16 of them. Just like when I had 1, 2, and 3, and I said, how many numbers are there? There's 3. And yet 3 minus 1 is only 2. So when you're dealing with a situation like this, you have to take the difference and add 1.
Okay.
Have you ever worked with a spreadsheet?
No, I don't believe so.
Which has rows. You can be on row 2, and your data goes all the way to row 141. Well, how many rows do you have? You don't have 141 minus 2. You have 141 minus 2 plus 1. And if you don't understand it, that's why I use 1, 2, and 3. If I have row 1, row 2, and row 3, and I say, how many rows do I have? Well, you know there's 3 rows, but if I subtract 3 minus 1, I only get the number 2. So in those situations, always remember you have to add 1. And if you forget how it goes, whether you add 1 or subtract 1, go back and solve that problem. How many rows are there between row 1 and row 2, counting row 1 and row 2? Well, there's obviously 2 rows, but 2 minus 1 equals 1. So you can't just subtract them.
Okay.
Which means this is 16, not 15. So there are 16 marbles that have the number you want on them out of how many?
Out of 45?
45. 16 out of 45 is the answer we're looking for.
It's not over.
Excuse me. Without replacing the first marble.
Oh, so 40.
So there's 44, which is
Okay,
6.
so
Yeah, there is that answer on there. It just, I need to divide top and bottom by 4 to get 4/11ths.
oh, simplify.
Yeah. Now that's a pretty tricky problem. It forces you to know that when you have 29 through 44, you don't have 15, you have 16. And it forces you to remember that you didn't replace that first marble, so there's really only 44 marbles left after you draw the first marble. And 16 of them are marbles that you will find favorable. So it's definitely 16 over 44. All right. Let me go to the next page. I'm going to try not to spend too much time on these hard problems just because I don't think it's the best thing for us to do. Okay, these problems I love. What's the perimeter of that figure? Didn't we have a problem like this already or not?
Yeah.
Good. What's the perimeter of that?
So don't you have to like split it into 2?
No. That actually is not going to work. Yeah, I guess it would work. Now, the key to remember is when you have a rectangle, we know the perimeter of that rectangle. If I take out a chunk of it, like this, the perimeter doesn't change. Notice why it wouldn't change. This little bit right there is that little bit right there. This little bit up here is that little bit right there. The horizontal part there is that part right there, and this horizontal part is that part right there. So notice the perimeter of the full rectangle is the same as the perimeter that has this corner cut out.
Okay.
So given that is true always, no matter what the shape is, in other words, in our case, we have a figure like this, well, the perimeter has to be the same as that full rectangle. What's the perimeter of that full rectangle if I were to draw the full rectangle? What's its base?
Would it be 4?
What's its base?
How do you figure out the base?
8. When I say the perimeter of the full rectangle, I mean this full rectangle. In other words, if I draw a dotted line up to there and over, that's the full rectangle. Well, we already know the base and the height of that rectangle. It's 8 by 5. So what is the perimeter of an 8 by 5 rectangle?
40?
That's the area.
Oh.
Perimeter is add them all up.
So that one's 26.
That's the answer. In other words, what I'm trying to say is the perimeter of this rectangle is exactly the same as the perimeter of that rectangle, even though this isn't a rectangle. This is a rectangle with a corner missing.
Okay.
The absence of that corner doesn't hurt, doesn't change anything. This is exactly the same problem as what is the perimeter of a rectangle that's 8 by 5? Now, this could be done the harder way, although, yeah, because we know that's 2, and we know that's 4. So if I label that 2 and label that 4, then I can just add up all the sides. That's not a bad way to do it either. That's a pretty easy way to do it. In other words, I know that's 2 because 3 plus 2 equal 5. And I know that's 4 because 4 plus 4 equal the 8. Well, that gives me 26 also. It's just that I really want you to see this relationship here, that taking a notch out doesn't change anything.
Okay.
In other words, if I say, give me the perimeter of this, it's the same as the perimeter of the 8 by 5 rectangle. Because all I've done is taken a notch out. This perimeter here, this part of the perimeter, is the same as that part of the perimeter. You see why?
Yeah.
Okay. So, in other words, when you see a problem like that, you don't have to do it the hard way by figuring out that side and that side. And some of these you can't figure out those dimensions. That's how hard they are. This one they actually made it easy in that you could figure out that that's 2 and that's 4, and you just add up the numbers. But this other principle is a more important principle to know, because you'll see problems where they'll give you this notched figure and they will not give you the information that even allows you to figure out what these dimensions are. So you can't figure it out the easy way on some of those problems. And you have to know that the notched figure has the same perimeter as the unnotched rectangle would have.
Okay.
All right? All right. This is remember there's 2 questions on conic sections. This is one of them. And they're actually pretty easy. Well, okay, they give us 4 points. Let's plot them. 0, 4, 4, 4, 4, 0, and 0, 0. They make a square. There is a circle inscribed in the square. What is the equation of that circle? First of all, let's talk about the general format for the equation of a circle. Something like each of these. Remember what it is? There's the general format for the equation of a circle, and there's the general format for the equation of an ellipse. You need to know both of them, because you're going to get 2 questions on the test regarding circles and ellipses. And these aren't going to really be that hard. The formula is x minus h squared plus y minus k squared equals the radius squared. Well, we know a lot of information about this circle. We know h, we know k, and we know its radius. Do we not? H and K are the center coordinates of the circle. Always, without the square. What are my coordinates of the center here? If this point is 4, 4, and this point is 4, 0, and this point's 0, 0, and this point is 0, 4, what are the coordinates of the center of that circle?
So wouldn't it be half of each point?
So, what is it?
2, 2.
Okay. So, h is what?
2.
K is what?
2.
What is my radius of the circle? What's the distance from here to here?
4.
What's the coordinates of that point?
2 and 2.
So how far is it from the y-axis to the x-coordinate?
2.
So my radius is 2. So now plug h, k, and r into that to see what we get. And then we'll find it on here. So what do I got? H, x minus 2 squared.
Plus y minus 2.
Squared.
Equals 2.
Equals 2 squared. So that's what we're looking for. Do we have it on there? No. Ah, C.
Okay.
Okay? What is the general equation of an ellipse?
Isn't it the opposite? Or
It's close to a circle. It's not the opposite. It's a little different. That's the same. That's the same. This is divided by a squared. This is divided by b squared. And the whole thing's equal to 1, not r squared. So this is an ellipse. And I don't know what else to do, but just you got to memorize this. There's no way to figure it out without memorizing. Now, what are A and B? First of all, H and K are the center of the ellipse. So if I had an ellipse like this, and that was 2, 2, then H would be 2 and K would be 2. What is A? A is the long radius. B is the short radius, even though they're not called radiuses. That's what I call them.
so
You know what I mean when I say the long radius and the short radius, right?
I understand long, but I don't understand short.
Okay, an ellipse has major vertices there and minor vertices there. So A is the distance from the center of the ellipse to the major vertex, C. B is the distance from the center of the ellipse to the minor vertex. B is always less than A.
Okay.
Okay? So
how do you know if you're using an ellipse and then it's problem?
well, because notice what the circle is. These are the only 2 you're going to need to know. Look at these carefully and see how they differ.
divided?
Well, the x term is divided by a squared, which is a different number than b squared. So you'll know whether you're dealing with, well, the problem will probably tell you it's a circle or an ellipse. So you probably don't need to know which it is. I don't know. We'll find out as we encounter other problems about conic sections. But primarily, if you're given something like x minus 3 squared plus y plus 2 squared equals 16, that sure looks like a circle, right? Because it's r squared. I don't have any denominators. All right, let's go on. $60. Normally 60 is a really hard problem. This is real easy. What's the price on Wednesday?
So would you divide 60 divided by 1.5?
No. Price was reduced by 15%. What's 15% of 60?
Did you divide by 0.15? Like, how do you
Multiply by 0.15.
Okay.
The word of means multiply. If you go into a store tomorrow and you want to buy a dress that's $100 and they say we're going to reduce it by 15%, what's the price of the dress going to be?
400? I don't think that's right.
Okay, you got a $100 dress that's being reduced by 15%. What's 15% of $100?
Isn't it 75? No.
Of means multiply. 0.15 times 100 is what?
15.
Okay, so your dress would be 85 bucks, right?
Yeah.
Okay, so that's what's going on here. They're reducing this skirt by $60. So how much, I'm sorry, the skirt started out at 60, but they're reducing it by 15%. So what is 15% of 60?
9.
Okay, so on Wednesday, the skirt's going to be priced at $51, right?
Yeah.
Okay. 2 weeks later, it's reduced by another 20%. Not the 60 by 20, but the 51 by 20. So what is the new price 2 weeks later?
I got 10.2, so would it be
And then you have to subtract that.
41?
So 40.8. $40.80 is the new price of the skirt 2 weeks later. Well, what percent of the original price is this last price? How am I going to get that? What does it mean? What percent? If I know the two prices, this price is 40.80, and the other price is the 60 was the original, what percent is 40.80 of 60? How do you do that? How do you get that answer?
Do you divide?
Yes. What by what? The original is always in the denominator.
Yeah.
So tell me what that percent is. You have your calculator?
Yeah, it's 68%.
Okay. Good. So all we had to do was figure out what the final price was, divide it by the original price. And when I say you always divide by the original, if I have something priced at $100 and I'm going to raise it to $140, what percent have I raised it? Well, I've raised it by 40 bucks, and you always divide by the original, not the new. So I don't divide by 140, I divide by 100. So I've raised it by 40%. If I decrease it by $20 down to $80, well, I've decreased it by 20. I still divide by the original, 100. I have decreased it by 20%. And that's the only two things you have to deal with, are increase by a percent and decrease by a percent. And when they want to know what the percent increase or decrease was, you always divide by the original, not the new.
Okay, that makes
Okay?
sense.
Yeah. All right, we finished one full test. Now we'll start another one. We'll get back to some easier answers. Easier problems, I should say.
Yeah.
Apologize for the blurriness. Must not have been having my hand steady when I took the pictures. I put all of these in by hand.
Oh.
I mean, I take pictures of the book and put them in.
Yeah.
There's an easy way and a hard way to do this. Let's do it the hard way. Okay. What is x equal to?
N? No. How do you...
Well, solve that first equation for x.
Do you equal them together, or you can't solve x?
Now, forget this one for a moment.
Okay.
Solve this first one for x as best you can. You can't solve it for a number, but you can solve it for x as a function of n. Isn't it equal to n minus 3?
Yeah.
Okay. Now, plug that in over here for x. What's this equal to?
2n minus 6 plus 6.
Which is?
I'm not very good at negatives and positives.
You don't know what plus 6 minus 6 is?
No, I'm just like, it kind of confused me when the negative is put in front. Or there's a negative.
Well, 6 minus 6 is 0.
Okay.
Minus 6 plus 6 is 0. Minus 10 plus 10 is 0. In other words, minus x plus x is always 0.
Okay.
So what is this expression equal to?
2n.
That's our answer. Now, that was the hard way. There's a shortcut if you happen to notice it. What's the relationship between 2x plus 6 and x plus 3?
They both are like, I don't think I'm going to say this right, but they're both like the same equation, kind of.
This is double that.
Oh.
Right?
Yeah.
If I multiply this by 2, I get 2x plus 6. So if I notice that this is double what this is, then this has to be 2n without doing any math at all. All I'm noticing is that that is precisely double that, which means it has to be 2n, not n. which was a lot easier, right?
Yeah.
And they put lots of problems like that. Whenever you see a function and another function, the first thing you should do is check, well, is there any flat relation? If that was 2x plus 5, I can't do anything. I got to do it the hard way. But the moment I see that it's precisely twice this, I have my answer instantly.
Oh, that was a lot easier than we did.
Yeah. So A times B minus 2C. Distribute that for me. That's all it's asking you to do. It's the equivalent of what?
AB minus 2A. See?
Is that answer on there?
Yeah.
Okay, that's it.
Like the easier ones.
Yeah, really. Well, that's why you want to make sure that most of your effort is spent on the easy and medium ones, and you don't spend all your effort on the 10 hardest. That wouldn't make any sense at all. You could spend 6 minutes on the 10 hardest problems each and probably still not get them right. Maybe get 3 of them right. But you'd be much better off spending that 60 minutes on the 50 easiest and medium hard problems.
Okay.
Okay. Which 3 numbers should be in the blanks below so that the difference between consecutive numbers is the same? Also a very easy problem. In other words, we have a sequence of numbers here that are all separated by what amount?
No.
The difference between consecutive numbers has to be the same by the time I fill in all these blanks. Well, what amount are they separated by?
7.
Okay. So this first number has to be what?
No. A negative 4.
Uh-huh. I don't have to go any further. There's only one answer that's got negative 4 is that first number. Notice that if I put the 17 in there and the 31 in there, they're all separated by 7.
That's easy.
But I didn't have to go far. They didn't give me multiple answers that all had minus 4 as the first term. So they made it really easy for me. As all I had to recognize is that they were separated by 7 and figure out what the first term is going to be, which is 3 minus 7 equals minus 4. All right. It is 7 o'clock. I'm sorry, I didn't notice.
You're fine. I didn't either.
Yeah. Boy, those hard problems really make me not notice time. So we've gotten through 3. I will make a note, and we'll pick up next Sunday night.
Okay, thank
with,
you.
With easy ones, since
Okay.
we're on 4. Yeah, it's rough to start on 51. That's no fun for anybody. So I'll talk to you in a week, Lauren.
Okay.
All right.
Thank you.
Bye-bye.